and apple don't exactly like each other. Why would they stream? Oh, never mind.
All right. So, just to back up, we're on MSP Unit 2, Lesson 5, talking about speed. We've talked about the units of speed, having to deal with something with length. It could be meters, miles, kilometers, or inches. What about time? Somebody give me some examples of some time units. Erica. Okay, so we have hours. Yep. Savannah? Seconds. What else? Yep. Minutes. M-I-N for minutes. Very good. Yes. Ariana? Milliseconds. M-S stands for milliseconds. Okay, and then we'll stop right there. Dot, dot, dot. There's plenty more. Now, what about the units for speed? What do we think? We've got length units, we've got time units. How do the units for speed factor in here? Yeah.
Like miles per hour.
Okay, miles per hour. It's a length unit over a time unit. Give me another example based on what we have on the board. Someone other than Emma, though you've done a very good job. Colby.
Meters per second.
Meters per second. Okay, what else? Jaden.
Miles per hour.
Miles, we just did miles per hour. Give me a new one.
Feet per minute.
All right, feet's not up there, but that is a length unit. Feet per minute would be a speed unit. Emma?
Inches per millisecond.
Inches per millisecond. That's actually pretty fast. Just so you know. Okay? Reagan.
Miles per second.
Miles per second. That would be very fast too. Very fast.
That'd be a plane.
Okay. Now, shh. Suppose for a moment that we didn't want to find speed. Let's say we knew speed. Okay? We knew speed and we knew something else. Okay? So, I'm going to go ahead and do something like this. Let's say that I wanted to isolate time. Okay? Time or distance. Let's do distance. So I'm going to write my formula. S equals D over T. Now, think back to last year. Think about math for a moment. We have, what do we call these letters in math terms? Savannah? Yeah, just like in science, unknowns, things that can have change. All right, speed can be different, distance can be different, time can be different. They're variables. Okay? V-A-R-I-A-B-L-E-S. Variables. S equals D over T. Variables. Now, in algebra states that I can move variables around so long as I do what when I'm moving things around? Yeah.
You only change one.
Okay, if I'm only working with one thing at a time, that's a good idea. And what else in a math problem? What is the golden rule of mathematics? The golden rule. Colby? Oh, what I do to one side, I must do to the, what I do to the top, I must do to the, what I do to the left, I must do to the, what I do to the in, I must do to the, exactly, we're getting the idea. Everything is done what's called duplicate. If we do it to one side of an equation, we have to do it to the other side of an equation. So let's say for just a moment that I want to get D by itself. Okay, I want to get D by itself. Savannah, suggest something we might try to make this happen. What do you think?
You would multiply T.
Yes, fantastic. I would multiply by T. Let me go ahead and do this in red. And because it's a fraction, I'm going to do T over 1. I can do that. Anything can be written over 1. Not 2.
3.
No. 1.
5.
1.
6.
1.
10.
1.
1 in there.
11.
1. 1.
11.
Okay.
111?
Now, Emma.
Could you divide by T?
Without because you already divided.
Because T is already in the denominator, by dividing by T, I wouldn't actually move T. What I'm trying to do is get T away from this side. What I've done is multiply by the reciprocal. If I were to divide by T, what would end up happening is T would actually get more complicated and stay on the same side. Now, I haven't completed my golden rule. What do I need to do here? Anna. I got to do it by the other side. What happens over here? What happens to those T's? They cancel out. They cancel because I have 1 in the numerator and 1 in the denominator. Okay, it's called cross simplification. What can you not do in cross simplification? You cannot do it across a what?
Equal sign.
Can't do it across an equal sign. But as long as they're on the same side, like I see here, I can simplify these. If there's a t in the top and a t in the bottom, that's fine. They can go away. I've moved t to the other side, and so I am left with s times t, I like doing it in alphabetical order, equals d. So this equation is just a modified version of our original, but the advantage is here we're solving for speed, here we're solving for distance. Yeah, let's take this one step further. Let's say, what is the last variable that I need an equation for? I've solved for speed, I've solved for distance. What do I need now? Not length, that's very good guess. Very good guess. Here, I'll give you an example. Time out! Correct. 10 points to Gryffindor. Okay? Absolutely. Of course, Gryffindor. No, Slytherin. Gryffindor.
I'm awful puff.
All right? You're a puffer, all right. Okay? So, here's what we're going to do. I'm not going to work with this equation. I'm going to work with this one to find time. How could I get t by itself here? Okay, I'm going to give Gabby a shot. Gabby?
Divide by s.
Yeah. Notice I'm multiplying. I'm going to do the opposite operation. I'm going to go ahead, I'm going to divide by s. Now, what I do to one side, I do to the other. What's going to happen to my s's over here? Ellie, what's going to happen to my s's here? They are going to cancel out. Go away. Adios, amigos. They are going to disappear. Okay. So, the s's go away, and now my equation for t, okay, is going to be t equals, and what am I left with over here? Yeah.
D divided by s.
D divided by s. To summarize, s equals d over t. D equals s times t. T equals d over s. 3 equations that I can use to find either speed, distance, or time. Now, will you have to do that algebra every time? No, you won't. Okay? I'm going to actually give you a little bit of a shortcut now that we've done this. I'm going to give you a little bit of a shortcut. Here's what this looks like. It actually has all 3 in it. Okay? So, this is what it looks like. Okay, very good. It's a triangle. And I'm going to put D.
How big should this triangle be?
Whoa.
Like an entire
S. T.
Oh, I thought that was a big T. The D looks like
Okay? And it's actually going to be on your practice problems for tonight. So you have a physical copy of it. Let me explain to you how this works. Okay? Keep in mind that our original equations are right here. So I'm going to reference these. Let's say I want to find speed. Speed. My original equation says, Mr. Hogel, what? I have to do what? Distance divided by time. Speed is distance divided by time. See how the D is over the T? When you have something on top of another letter, it's division. Okay? What about time here? It's distance divided by, yeah. Emma?
Oh, speed.
Speed. If I'm trying to find time, I have distance divided by speed. What about if I want to find distance? I cover distance up. Now they're next to each other. That's the same as multiplication. That would be speed times time. Okay, so let me repeat. If I want to find speed, distance divided by time. Time, distance divided by speed. Distance, speed times time. This triangle has all 3 equations in one spot. Okay?
Wait, how?
Say what?
This is amazing.
You can do this for a lot of equations. There are actually like 5 or 6 equations in science that use this same kind of idea. Okay? Same idea. So, I'm going to stop here for just now, and we're going to try some of these together. I'm going to show you kind of some tricks of the trade. Okay? So, let me go ahead and stop this recording.
Means